Hey guys, this is lesson 5, exercise 1C, solving linear equations. Essentially this exercise is looking at linear equations, or specifically equations, so something that has an equal sign in it, and trying to solve for an unknown or for a letter. The word linear just means that if we were to graph these types of equations, more specifically anything with two variables or two letters, when you graph it, it creates a straight line. Okay, so don't let this word be intimidating, I guess. It's just a type of classification for what type of equation we're using. Okay, so an equation is a mathematical statement that says that two things are equal. Okay, so the left hand side is equal to the right hand side. All of these examples here are equations, and we all know, we'll just look at the first example. X take away 3 is equal to 5. We know using logic that this number can only fit, this letter rather, can only fit one number, and that's number 8. Because 8 minus 3 is equal to 5. Now, I'll be showing different tactics and different skills in order to solve trickier linear equations. Before we get to that, just have a look at these different types of examples here. Pretty much when any of these equations, or anything that has an equals, has a letter involved, and it can be more than one letter, as long as all of the letters has a power of 1, remember the 1 is not generally shown there, it's considered a linear equation. Now it's not necessarily a fact to remember for now, but if you're planning on doing general maths next year, this fact is very important. So just have a look, this is linear, so is this, so is this. These two, even though there are two variables, both of these powers are 1, you just can't see them. This is linear, but as soon as we get to these two, they're not linear because the power is squared. Oh, the power is 2. And this just talks about when you graph these two, specifically this one, it doesn't create a straight line, but essentially a curveball. Okay, that's why it's not linear. Okay, but you don't need to necessarily worry about that for now. So, once we have identified a linear equation, the next step is to find the unknown value. This is the process called solving the equation. So when we solve the equation, we're trying to get the unknown, generally a letter, yes, the scary ones, we need to see letters in maths. We're just trying to get this by itself on one side of the equal sign. And when we do this, we apply what's called opposite operations. This is a table below to show you what opposite operation you need to apply to an equation to get a variable or a letter by itself. Plus, opposite is minus, minus plus, times and divide, they're opposites. The square root of a variable, its opposite is to square it. And the same thing vice versa. If a letter is squared, you square root it to get the opposite. Okay? So remember, an equation must always be balanced like a seesaw. In other words, whatever I do to the left, I also have to do to the right, or whatever I do to the right, I also have to do to the left. Okay? So a quick example of these four, x plus 3, this is addition. So to eliminate that plus 3, we do the opposite. So we subtract 3. The opposite of this subtract 4 is plus 4. Okay, so because the opposite operation, in this case, sorry, is plus. This is 5x, but it's actually 5 times x. So to use the opposite operation, you divide by 5 using division, and x divided by 7, or x over 7. To get rid of that divide by 7, you just times by 7 or multiply by 7. I'm going to leave this little opposite operation chart here, and the questions are onto the side here. So what you're going to do is you're going to copy these examples. Solve the equation x plus 6 is equal to 10. So x plus 6 is equal to 10. Now we know that this number is 4. It's the only number that can work. But I want to apply these opposite operations to get rid of this 6. I want to get x by itself. So the opposite of plus 6 is minus 6. I'll do it in a different color. Now I can't just simply subtract 6 from there. without also having to work it out on the other side. Now you'll see a few certain habits that I fall into. Feel free to copy it, but if you don't want to, you don't need to. It just makes it easy for me when I do the next step. So because I've just subtracted a 6 from here, what technically happens is that these two cancel out, because 6 take away 6 is 0, and that's the whole point. We were trying to get rid of this positive 6. What we're left with is just x by itself. But as a consequence of doing this, we have to subtract 6 from the other side, and 10 minus 6 is equal to 4. So in this case, we've got x by itself, and this is equal to 10 minus 6, which is 4. Now that we've got x by itself, we know what the solution is. Now this seems like an unintuitive way of doing this because we know that this answer is 4, but this process has to be shown when we get to tricky examples, which we'll get to later on. Okay. So the next example, 3y is equal to 18, and specifically 3 times y is equal to 18. This that's being applied is 3 times y. So I'm going to divide by 3 as it's the opposite operation. Again, whatever I do to the left, I do to the right. Now 3y over 3, or more specifically 3 divided by 3 is 1. So they don't necessarily cancel out to a 0 in this case, they cancel out to 1 or 1y. But when we have 1y, you just write the letter as is. So y is out by itself. But 18 divided by 3, this is going to be 6. And that's our final answer for this example. And that makes sense. 3 times 6 is equal to 18. So this is the only answer that will yield this equation here. Okay? Now, if you see some type of question like this, just as a little pointer, you can write the answer straight as x is equal to 4 or y is equal to 6, provided that it's only 1 mark that is up for offer. If there's 2 marks or anything more, you need to show this working out. Okay? You're still going to mark if you write the correct answer, but you need to show the working out. You have to show the algebraic working out. Okay? Alright, next one. Solve the equation 4 in bracket x minus 3 close bracket is equal to 24. Now there are 2 ways of solving this. There is a easy or quicker way, which I'm going to show you. So right now we can see that this x minus 3 is in bracket, and then it's being multiplied by 4. So what we want to do is we read this as 4 times in bracket x minus 3. And then we kind of work backwards. So the x minus 3 is together, and then the times 4. And that times 4, that last application that's being applied to this, is the first thing we're going to get rid of to get x by itself. Because it's times by 4, we're just going to write divide by 4. Now I just made a little bit of a mistake here. This should be 24 by 4. And again, whatever I do to the left, I do to the right. So in this case, these two turn into a 1, because 4 divided by 4 is 1. And what we're left with is x minus 3 is equal to 24 divided by 4. How many 4s go into 24 in this case? It's 6. 4, 8, 12, 16, 20, 24. You don't need to keep those brackets around there because it's done. And then now we apply the next operation. The opposite of take away 3 is plus 3. These turn into, cancel out to turn into a 0 to get x by itself. And what we're left with is 6 plus 3, which is 9. And there's our final solution. Substitute it back into the equation just to double check. 9 minus 3 is 6. 4 times 6 is equal to 24. So this is correct. Alright, 2 more solutions. Remember, feel free to pause at any time if you're still writing this down, and then once you're done you can continue. Okay, solve the equation 2 bracket r squared plus 8 is equal to 64. Now we do have, it is a linear, a non-linear equation, but just to see how this works, I'm going to apply the first opposite operation, which is divide by 2, because it's a times 2. This will then yield the number r squared plus 8 is equal to 64. Not 64, sorry. We've just divided it by 2. It's 64 divided by 2, so it's 32. Apologies. Okay, next step. The opposite of plus 8 is minus 8. So we minus 8 on both sides. Plus 8 minus 8 cancels out. We're left with r squared. And on the right hand side, 32 subtract 8, which is 24. Now, the opposite of squaring a number is to square root that number. And you've got the square root function on your scientific calculator. So all you'll do is just punch in the square root button and then put 24 in. And what you'll end up having is r is equal to, now these two cancel out to get r by itself. And the square root of 24 is 4.8989, which approximates, there's like a squiggly equal sign, this approximates to 4.9. Okay. I do want to round this to 2 decimal numbers, but if I put this number 9 up, as a consequence, this turns into a 9, so it's just 4.9. And the last example, this is a tricky one. We're going to solve the equation 2x plus 1 in bracket plus 3, 2x minus 8 in bracket as well is equal to 0. Now I'm going to try to write this a bit smaller than the other examples. And because I have a 15-minute restriction on this video, I'll try to be as quick as I can. Okay, the first thing we're going to do, I'm going to get a different color now, is we're going to expand these brackets, and this was from the previous exercise. The outside number gets multiplied with both inside numbers. So this has to be done first before we can then solve. Okay. Again, I know you made another silly error. This should be 0, not 8. This is 0 because it's right there, 0. Okay, 2 times x is 2x. 2 times 1 is 2. 3 times 2x is 6x. And 3 times minus 8, a positive times a negative, will give me a negative. So it's minus 24. This is equal to 0. Next thing, I want to collect the like terms. There are x's here, which I'll put a yellow line under, and there are normal numbers, which I'll put a green line under. 2 lots of x plus 6 lots of x's will give me 8x, and 2 minus 24 will give me minus 22. And this is all equal to 0. Okay, now I can apply my opposite operations because I'm just left with one letter. The opposite of minus 22 is plus 22, plus 22, and we're left with 8x is equal to 22. 8x is equal to 22, and divide each side